Hello everyone, am I audible? Hello everyone. Yeah. How is everyone doing? Did you guys utilize the weekends to revisit the lectures that we have had till now? Cool. Yeah, good to know that. Cool. So we are going to from today we are actually going to start looking at some real life systems and try to design them. Today's class I would also utilize to make sure that everybody appreciates that how do we go about any design question in an interview. Okay, so keeping in mind the interview settings, and not only the interview settings but also more or less the settings in which you would be asked to come up with system designs in an actual company as well when you would be working. This is the best way of actually approaching a system design problem, and we are going to discuss that today. So earlier I was planning to discuss Facebook Messenger today, but it would make more sense that we start with a simpler topic today, which is tiny URL. Let's start with that today, and maybe in next class or maybe in a couple of after a couple of classes, we can design Facebook Messenger as well. Okay, cool. So okay, before actually moving to the actual question that we want to discuss, let's actually understand that how would you tackle any design problem. Okay, keep one thing in mind, guys, that whenever you are giving a system design interview or you are in a real life company settings and you want to design a system, the problem would be very abstract. Okay, you are not going to get a list of features or a list of specifications from somebody else, right? That is a part of your job when you are actually designing high level scalable systems. Okay, so it's very important that you do the requirement gathering, you do the estimation, you do the trade-offs, and then you come up with a system design. Okay, so the problem is going to be purposefully left very vague and purposefully left very abstract so that you guys can pitch in and take the lead in trying to solve it. Okay, cool. So I will actually list down 4 points that all of you should remember while giving any system design interview, or in fact while designing any system whatsoever. The very first thing is that whenever you are given an abstract problem, you should first of all clarify all the features that your system should support. This in fact is also this basically defines the scope of the problem for you, that what is the scope of the problem that you're trying to solve. And this in itself is also composed of 2 steps. Step 1 is actually listing down all the possible features that you can see that an application can support over a period of time. Okay, so listing down all the features, or let's say listing down most of the features. This is the first sub part in this step. The second sub part is actually out of all the features that you have just listed, selecting a subset of those features which will be a part of your minimum viable product. Does it make sense? So figuring out what all features would be a part of your minimum viable product. What is a minimum viable product? We will be discussing that in a bit. So figuring out what all features would you want to have in your minimum viable product. This is the first part of the problem, first part of the solution. The second part that after doing this you must do is estimation of scale. So figuring out at what scale is your problem, right? So you will figure out what kind of a traffic are you going to see. Is it traffic or is it going to be write traffic, right? Then you will be figuring out what kind of a QPS do you want. Okay, you will be figuring out what kind of a storage would you have to support. Okay, so these kind of questions, estimating the scale for the problem that you are trying to solve is very important, because the moment you estimate it, you automatically figure out, okay, you automatically figure out that what all things are possible and what all things are not possible. Okay, so possible versus non-possible, these kind of things you automatically figure out the moment you do the estimation of skill. Okay, now Chauhan Prithvi has a question. He says, should I directly ask that I should build the minimum viable product? Okay, so Chauhan Prithvi and to everybody else in the class, no matter how redundant these things may seem to you at this point in time, and I'm pretty sure that these will not seem redundant to you once we have discussed several problems, you should ensure that in any interview you should not try to save your time out of cutting short on these steps. Okay, these steps are going to give the interviewer a lot of confidence that this person, the interviewee, knows his job. He knows how to approach a problem in a very, very structured manner, and irrespective if you feel that I'm maybe wasting my time and I should directly jump to the problem, you should never do that. In fact, you should never even directly jump to the minimum viable product instead of listing down a relatively bigger set of features. Okay, so list down a few features, then based on your discussion with the interviewer, say to them that in my minimum viable product, these are the features that I would want to have. Okay, so what is a minimum viable product? Let's actually discuss that right away so that everybody is on the same page. Minimum viable product by definition means the smallest feature set that you would want to have in the first shipment of your product. Does it make sense? So you want to hit the market, you want to build something and hit the market. The minimum viable product, a product which has all the basic features in it so that it can hit the market and maybe test the water as a control set of people respond to it, or let's say how does the market respond to it. It's only those features that should be there before you can actually test it, should be a part of the minimum viable product. Okay, so it's very, very important that you list down a few features and then say that these subset will be my minimum viable product. Let me give you one example. So when Google actually started as a search engine, they did not have any spell correct. Does it make sense? So Google did not have any spell correct when they would have launched their product for the first time. And let's say if you are mistyping a word, then they would actually come up with the articles which had that misspelling of the word. Does that make sense? अब क्या होता है कि the moment you mistype it, they will still come up with the articles with the correct spelling of that word before, and they would be themselves nudging you to say that maybe this is what you meant. But in the minimum viable product, there was no concept of spelling check, and whatever exactly word that you are writing, their algorithms would try to figure out the articles or the web pages which would actually have that exact, even though a misspelled word, that exact spelling of that word. Cool. So makes sense. So the second step is the estimation of scale, which allows us to figure out that what is possible, what is not possible. The third step that we have is now managing the trade-offs. So till this point in time, I'm pretty sure if you have attended the system design classes, you would have figured out that system design, high-level design is nothing but making some trade-offs, right? Selecting one option versus the others, right? So making the right trade-offs is a very, very important thing. And what kind of trade-offs am I talking about? So first of all, would you want to prefer, let's say, consistency, availability, or partition tolerance? Secondly, what kind of latency would you want your system to support? And then let's say, what kind of a replication would you want to have, and so on and so forth. What kind of a storage would you want to have, and so on and so forth. So all these questions के answer would be given to you. You would automatically figure out after you have done the estimation. Discuss these trade-offs with your interview. Okay, do you understand that this is the exact way in which you should be tackling any question in the interview? Does it make sense? And in fact, even in a company, when the product manager comes to you and say, hey man, we want to build a search engine, he would only say that. Now it's your job as a software developer or as an architect to go through these steps with your product manager and then try to make the right set of trade-offs, right set of decisions, design decisions for your product. And once you have done that, then this is the last point, which becomes very, very simple if you have done these first three steps properly. That is basically the actual architecture design. that now you actually come up with an actual architecture design, that how are you planning to tackle this problem. Okay, but make sure that you never jump to this without skipping the first thing. Okay, cool. I hope these steps are clear, and always keep these steps no matter whatever question you're trying to solve in an interview or in your real life. Okay, cool. Now let's come to the problem at hand for today. The problem at hand for today is that you want to design a system like tiny URL, or let's say bit.ly. What are these systems? These systems are URL shortening systems. Does this make sense to everybody? What is the problem that we are trying to solve? We are trying to build an architecture design for tiny URL or bit.ly or any system which can actually shorten the URLs for us. Okay. What is a good example where you would have seen these URL shortening services being used? Can you guys come up with some examples where you would have seen those? Okay, so LinkedIn, okay, Twitter, okay. So LinkedIn, Twitter, YouTube, these websites would be shortening the URLs themselves. Does that make sense? They do not fall back to a third-party URL shortening service, and they just give you a shortened URL themselves, right? What at this point in time we are discussing is that we want to use a third-party website or a third-party service to which we can give a genuine URL and ask that third-party service to give us a shortened URL. Okay, Lokesh is saying that my voice is breaking. Is my voice breaking for everybody? It's fine, right? Okay, it's fine. So Lokesh, maybe there is some issue at your end. Okay, lagging sometimes, I understand that, but please bear with me. There are some technical difficulties, but that's because of the lockdown and taking lectures from my home or from my friend's home. Cool. So let's take a good example that I have seen personally many times. Whenever you look at an Amazon product listing web page, okay, Amazon product listing web page. If you have looked at those pages, you would have realized that the URL is very, very large. Does that make sense? So Amazon product listing web pages ka URL are very, very large URLs, right? And now let's say you want to share those URLs with your friends, or let's say you want, or let's say it's kind of a system where you would, let's say you are some kind of a retailer who has some listing on Amazon, and now you would want to share that link with everybody in your contact list, that those people, if they want, they can buy your product from Amazon. Okay, cool. Now passing on that very big web page is not very feasible. The URL of the very big web page is not very feasible. Now you would actually want to use a third-party URL shortening website or service to actually get a shortened URL for that URL. Okay, cool. So this is a good example. So let's say you have a Amazon ka very large www.amazon.in/something a very big URL with the product listing. You can now actually, let's say, map this to a very small URL like bit.ly/ let's say ABCD. Okay, cool. So now let's look at the features for this URL shortening service. Can you guys help me with the features? Can everybody in the class help me with the features? Can you start typing some features that you would want to support here? Do not think about the minimum viable product. Just think about everything at this point in time. So yeah, very first feature, which is very, very simple, which is a must have, is that you should be able to take a URL and give back a shortened URL. Does that make sense? You should be given a URL which you should be able to reply with a shortened URL. The second use case, which is also very, very simple, is that you should take a shortened URL that you shortened before. Okay, you should take a shortened URL that you shortened before, and now give the actual URL. Does it make sense? So these are the very, very basic features that your app must support uh, if it wants to go live. Okay, cool. Can we list down some more features? Customizable URL. Moise is absolutely right. So you can have a customizable URL in which you can say that, let's say I want to give a specific tag to a shortened URL that I'm building. So let's say there is a web page which is a big web page of www dot something something something. You now, let's say, want to map it to bit.ly slash, let's say, Facebook, FB. Okay, so let's say it was a big URL for facebook.com, which was actually talking about some post. Okay, and now you want to map it to slash FB. Okay, so this FB is not a random hash that you are generating. This FB is a customizable thing that you yourself provided the service to use. Okay, so this can be another feature, customizable URL. Then what else? Responsive URL. What does that mean, Chauhan Prithvi? Repeat second feature. Okay, Archit, the second feature was that you should be able to take the shortened URL, a URL that you shortened some time ago, and you should be able to map it to the actual URL. Does it make sense, Archit? Okay, cool. So Deepika says expiry of a shortened URL makes sense. So let's say we want to have URL expiry. So shortened URL expiry. Anything else, folks? Okay. Sohail says URL must be unique. So Sohail, is that a feature of the website? So we are of the service, we are talking about features which the user is going to see, right? So URL should be unique. It's not a feature. Instead, it is something that you should be able to enforce while you are designing your system, right? Okay. So Abhishek says when we run the short URL in the browser, redirection to the original URL must happen, which makes sense. But that is try to understand that's not a system design problem as such. You would just, so let's say whenever a browser hits a bit.ly URL, a specific bit.ly URL, let's say slash abcd. Now bit.ly should be able to get back to you, give a response with the actual URL, and just do a redirection, right? So that's not a system design feature as such. Okay. How short should it be? Minimum length. Okay. Okay. So Vanessa, so we'll discuss that. So ideally, the idea for any shortened service would be that your URL should, a shortened URL should be as short as possible. Okay. A shortened URL should be as short as possible. Okay, cool. Unshortener. Moise, what does that mean? Does that mean that you would want to take a short URL and give a larger URL? Not a kind of a, okay. Screen stuck. Okay, is the screen stuck, guys? No, it's not. Number of redirections to a URL in a time frame. Makes sense. Samir raised a very, very interesting point. Samir is saying that having some kind of a count or having some kind of, Samir, I would mention a bigger, broader definition there. I would say that you want to add analytics for the URL. Does that make sense? That you want to build an analytics service as well. What does that mean? That means that you would want to tell the person who is using your website to do some kind of shortening that, hey man, I can tell you that the number of times this shortened URL was visited was this. The demography of the users was this, that is your URL was most likely used by people belonging to the age group 20 to 40 and so on and so forth. And let's say what kind of a geographical location did they belong to and so on and so forth. Does that make sense to everybody? So these are the analytics that you should be able, you can actually want to add in your system design. Folks, does it make sense? Okay, why does it make sense? Let me just explain it to you. So for example, I am running some kind of a marketing campaign, and I want to figure out how many people land at InterviewBit through that particular marketing campaign. Okay, or let's say if I am InterviewBit, and if I want to monitor how many people land up at InterviewBit from that particular campaign, do you guys know what do we do actually? Or what does any company do in that case? We just add a parameter in the normal URL. Does that make sense? So you guys would have seen that if you can go to websites like couponraja.com and something else, couponrani.com and so on and so forth, where you actually find coupon codes that you can actually go and apply at a particular website. You would see that there, the URLs that they give for you to click, those URLs have most likely added parameter. Have you guys seen that? In fact, you could also see that in let's say Amazon resellers, if you have seen that before. What is that? That is basically a way of tracking that from which source are the people, are the users landing at this website, right? So what do they do? If it's an internal campaign, you would just want to add a parameter at the end of the URL, so that you know how many people are coming to your website through this particular campaign. Okay. But now let's say there is an external entity who is running a campaign for InterviewBit. Okay. And they want to also at their end figure out how many people actually clicked on the link that they shared with their prospective audience. Folks, is it making sense? Now, if I am a third party person and I do not have the access to InterviewBit's database, I do not know that how many people actually land at InterviewBit from my source, and maybe InterviewBit is fooling me and telling me a shorter number. So how do I actually help that? A very simple way of doing that would be to use a third party URL shortening website. Just give them the URL that you want to have, get a shortened URL from them, and then use that shortened URL to do your marketing, and then ask tinyurl or bit.ly to provide you the statistics for the users that actually clicked on that shortened URL. Does that make sense to everybody? Cool. So this is again a very interesting use case of websites, URL shortening websites. Cool. So these are the four or five features that I have written here. Can we think of anything else? So we talked about the expiry. Maybe we can also have a force deletion. So let's say I created a shortened URL and I now want the folks to stop using it. Okay. Should I actually be able to go to tinyurl.com and ask them, hey man, please remove this mapping? Yes, maybe that is also a valid feature, right? Neeraj is asking, can advertisement be a feature here? Neeraj, advertisement will be a use case. We are talking about actual deliverable features for the end users. Okay. So advertisement here would not be a feature. Chauhan says, okay, responsive means faster redirection. That makes sense, Chauhan, but that's not a system design problem as such. You are going to return the URL and it's now the browser or the kind of a response that you want to give so that it can be redirected. Good. Do we need to have a rate limiter here for shortening requests? Okay, that also makes sense, Samir. So Samir is saying that we should be able to have a rate limiter as well. So let's say bit.ly is free for folks to use, right? But I would want to ensure that there is a limit to the number of URLs that any person without paying me anything is using. Does that make sense? So I should also be able to have a rate limiter, which would allow me to say that, okay, in this particular time frame, this particular user can only shorten these many URLs. Does that make sense? Okay. Now let me take Ayushi's question. Ayushi says, what if InterviewBit uses another URL shortener to change the URL that is monitored by external entity? Will he still be able to track the count? Ayushi, I did not get it. Do you want me to unmute you, Ayushi? I did not get it properly. Do you want me to unmute you? Sure. Yeah. Hey, Ayushi. Hello. Hello. Can you guys hear Ayushi?
Hello.
Yeah,
Hello.
Yeah. Please go.
Yeah. So my question is that that the external entity that you mentioned, that that entity is sharing a URL with InterviewBit, and it is tracking it on their own end. So what if InterviewBit also uses another URL shortener and shares that link with its users?
Okay. So I see that there is some confusion. Let me just clarify that. Good that you asked it. So the point is what I try to say, and please everybody in the class, please pay attention. The point is that let's assume there is a URL for InterviewBit, which is, let's say, interviewbit.com slash some particular academy. Let's say TechVersity admissions, something like this, right? Some endpoint for InterviewBit. Now, I am an external marketeer. I want to get more people to InterviewBit, and InterviewBit, let's say, is going to pay me for that. Okay. Now, if I am an external marketeer, one option that I have is, Ayushi, that I can just share this with every client of every, let's say, prospective client of mine, and tell them, yeah, please go and register on this website. Does that make sense, Ayushi?
Okay.
One way to track how many people did I refer to InterviewBit would be that InterviewBit can actually add a parameter at the end of the URL, which would allow them to track, InterviewBit to track that how many people actually landed at this page through this parameter. Does it make sense?
Yes, yes.
But that is the information which is there with that organization, and me being a third party vendor would not have that information. If I do not have that information, one way of me going around this would be that whatever URL they have given me to promote, I can just call a third party, let's say, shortening website, bit.ly, shorten that URL and make it, let's say, www.bit.ly slash interviewbit ADM slash, let's say, name of my company, which is, let's say, anything, let's say ABC. Okay. Now what happens? Whenever anybody, now I will be sharing this URL with all my prospective clients, and whenever anybody hits this URL in their browser, what happens? You would agree with me that the request should actually go to bit.ly. Does that make sense? Because what will the browser do? The browser will go to the DNS, figure out the domain mapping for this bit.ly, figure out the mapping, and then make a request to bit.ly servers. Now bit.ly know ki acha, I have one more request coming from this particular URL, and bit.ly will simply return back to the user with this actual URL. And now the user will automatically be redirected to this actual URL. But now, it's not only InterviewBit who has the information that how many people are coming from this third-party marketeer, but bit.ly also has the information.
Right.
And now the third-party marketeer, just because he has a deal with bit.ly, because he's paying them some amount, can get this information that how many people, let's say, actually managed to go from his marketing, and he can charge InterviewBit accordingly. Does that make sense?
Yes, it's clear. Thank you.
You're most welcome, Ayushi. Okay, good. I hope there is no doubt remaining till this point in time. Can we actually move ahead? Okay, so Sukanya says, maintaining user profiles. So let's say you would want to log in, register so that users make sense. So another feature that you would want to expose would be profiles. So maintaining profiles. Okay. Then Neeraj says get updated URL. If I already have one and I want to get new one for the same URL. Okay. Makes sense. So Neeraj, the point is that the services that are actually out there in the world today, if for example, I went to that service and I got from them a shortened URL for a particular website, for a particular URL. Now let's say sometime after you also go to them with the same URL and you are also looking for a shortened URL, most likely for most of the services, they are going to give you a different URL, shortened URL. Does that make sense? Even though both of them are mapping to the same URL. Why is that the case? Because if they are doing some analytics at their end, they would want to keep the data segregated. Does that make sense to everybody? So irrespective of whatever is the underlying URL that you are trying to shorten, if different people are trying to shorten it at different instances, you should be getting a different shortened URL. Does it make sense to everybody? Okay. Cool. Okay. That's it. Maybe sharing limits of URL depending on payment model makes sense. Makes sense. So you maybe can have rate limiting not only for creating URLs, but you can also have rate limiting, let's say, for viewing URLs, which may make sense in some of the business cases. Cool. So these are the features that you would want to list down in a real interview scenario, and then discuss with the interviewer that what all features would you want to have in your minimum viable product. Okay, you would directly tell from your side that these are the features that you feel must be there in your MVP, and you are going to design them. But if the interviewer seems a bit uneasy and he or she wants to add some features, you can very well add those features as well in your minimum viable product. Okay. Cost up makes sense. You should actually clarify this requirement from the interviewer, that whether if different user comes with the same underlying URL, would you be actually mapping them to different shortened URLs or to the same shortened URL, and whatever reply the interviewer gives, utilize that reply to build a system. For now, let's assume that if another person is coming, he or she should be getting a different shortened URL. Does it make sense to everybody? And does it make sense to you, Costa? I hope it does. Cool. Makes sense. Now, without a doubt, the very first feature should be a part of the MVP. Does that make sense? That you are given a URL, you would want to get a shortened URL. Similarly, the second must also be a part of the MVP, that you are given a shortened URL and you would want to figure out the actual URL. Okay. Now let's look at these other things. My submission would be that if possible, always try to build the minimum viable product. जिसके अंदर minimum word का मतलब minimum ही है, right? Always try to look at the features which are bare minimum for your service, and then maybe wait for the interviewer to tell you what features does he or she want to add. Okay. If you go the other way around, if you actually select a lot of features thinking that that would impress your interviewer, and then end up confusing yourself and not able to develop a solution for it, then that would be a much worse place to be at, rather than starting with a very minimum viable product and then asking the interviewer if he or she wants to add something. And if they want to add something, they will most likely want just a single or a couple of things to be added, if at all. And then you can very easily try to tweak your system to add those things as well. Does that make sense to everybody? So never ever start with a very big system that you want to design. Always start with a minimum viable product where minimum actually means minimum. Okay. In this case, if you are giving an interview, these are the two features that you must have. This is the minimum viable product. If you should start building it, then the interviewer most likely will come up and say, for this problem, because this happens to be a simpler problem, most likely he or she will say that, okay, maybe you should be able to provide customizable URL support as well. Or let's say maybe you should be able to provide rate limits. Or let's say maybe you should be able to provide analytics, and so on and so forth. But at the very first instant, always try to start with the minimum viable product. Okay. For now, we are going to start with these two things. And then at the end of the lecture, maybe tomorrow, if you guys want me to add any other thing, just tell me one more thing that you guys want to add, and we would try to modify our design to add one more thing. Does that make sense? Let's start with building a system which happens to manage these two cases. Does that make sense, folks? And then we can add one or two features thereafter. Okay, people are not replying today, and the problem is that I am also not feeling very well. I am feeling a bit down today. My health is not very well. So I would want you guys to please reply quickly so that I do not end up asking a lot of things. Okay, cool. Thanks a lot. Thanks a lot. Cool. So we have listed on all the features. We have the MVP in front of us, which is the version 0 that is going to hit the market. Now let's actually figure out the second step of the problem. Okay, so we are done with the MVP, that we want to build two features, that you give a URL, get a shortened URL, or you give a shortened URL, get the actual URL. Cool. Now let's actually do the estimation of scale. Okay, let's try to estimate the amount of traffic that your system is going to get. Okay, do you appreciate that there are going to be two kinds of traffic? One kind of a traffic would be that you want to write, which would mean shorten a URL. Folks, does it make sense? One kind of a request would be that you want to shorten a URL. The second kind of a request would be a read request in which you want to access a shortened URL. Does it make sense? Uzair, you're absolutely right. Cool. Now, let's assume you are actually building a $1 billion company. Okay. Let's assume you are building a $1 billion company. And now if you're building a $1 billion company, you can very safely assume that the number of reads every day would be of the order of 1 billion reads every day. Okay. So let's assume that the number of accesses of shortened URL that you're going to see every day is going to be of the order of 1 billion. Does that make sense, folks? Now, the second thing is that, as some of you have already told me, the system is going to be read heavy. The reads are going to be much, much more than the number of writes. Because if you have 50 friends, you shorten Amazon product listing URL. Now you're going to share that URL with 50 friends. Let's say every one of them open that URL twice on average. So you're going to have 100 requests for one single write that you're going to see. Okay. On the other hand, if you happen to be a very lonely person, then maybe you just created a shortened URL for yourself and you only go back and access the shortened URL. In that extreme case, it would be a 1-to-1 ratio. Otherwise, the ratio is going to be very much tweaked in favor of the number of reads. Does it make sense, everybody? Okay. According to my assumption, you guys let me know if you have different point of view. I would assume that it's a 1-to-100 ratio of read to write. Okay. So Sukanya does that sometimes. Okay. Cool. So I would assume that it's a 1-to-100 write to read ratio. Anybody else with a different estimate? Cool. Now, if you have 1 billion reads per day and your write to read ratio is 1:100, then the number of writes would be, folks, 10 million. Right. So what if you put a shortened URL link on Twitter? Right. So again, depends how many followers you have, Kaustubh. Yeah. So let's assume it's 1-to-100. You can assume it to be a bigger number as well. But the problem with assuming a very, very big number would be that the interviewer would feel that you are running away from a complex problem and try to reduce the number of requests by hook or crook. Okay. So it's always better to not be on very, very safe side and assume numbers. It's always advisable to be relatively aggressive while deciding your numbers. Okay, cool. So we have 10 million writes per day, but the reads will be more anyway. That would still be a good problem to solve. Exactly, Moise. But when you actually have more writes as well, the problem, the writes are relatively more complex than reads. Moise, I hope you understand that. Writes are relatively more complex than reads because in writes you have to think about a lot of things, consistency being one of them, persistence being one of them, and so many other things that we discussed in the previous classes. So writes are definitely more complex. Cool. And also the more writes you have, the more storage space you require, and the more storage space you require, the different kind of a problem that you're solving actually. Sukanya, we are going to answer that question when we actually move to the third point. We are at the scale estimation point. Okay, cool. Now, but for this problem, if you guys do not have any issue, I would want to assume that I have 1 billion writes per day. Why do I want to say so? Because I want to assume that it is a very, very large system and see how does the problem look at that scale. Does that make sense, folks? So let's actually look at 1 billion writes per day. If you guys are fine with that, if you guys want me to use 10 million, I can use that as well. Nothing changes at my end. But I would just, for the sake of, in an interview, you should not be assuming this. but just so for the sake of understanding big numbers, let's actually use 1 billion writes per day. Cool. Now you have 1 billion writes per day. Yeah, it's a $1 billion company, so let's assume it has 1 billion writes per day. Cool. Now, once you have this number, can we actually figure out the QPS? Or first of all, should we actually figure out the QPS? Yes, we must, right? So whenever you have the queries, as discussed in the previous classes, you always talk about queries per second. Okay. So here, I would try to figure out the QPS. For that, what would I do? I would take 1 billion divided by the number of seconds that I have per day. Okay. Can somebody solve this for me? This will become 10 to the power 4 multiplied by 1864. This should be something like 1.1 maybe. So this should be something like 11,000. Does that make sense? So it should be around 11,000 QPS. Cool. So you should always be doing this back of the envelope calculation. So as to impress, these things do actually make a lot of difference in the interviewer's psyche. Okay, cool. So you have, let's say, 11,000 queries per second. Makes sense. Now let's actually not stop there, but in fact discuss about. Okay, let's actually look at 11,000 QPS for now, and we'll be coming back to it. Now let's actually try to estimate. It will not be exactly Chandan. So that's what I just left for now. Let me in the meanwhile also try to figure out that how much will be the space requirement there. Okay. Moe says QPS includes both reads and writes. So ideally you should be computing a different QPS for reads and a different QPS for writes. So you should be saying that the read QPS is this much and the write QPS is this much. Does that make sense, Moise? And to everybody else in the class, you should be doing different QPSs for different kinds of operations. Cool. Now let's assume that if you have this kind of a QPS, let's hold on for a while here, and let's try to look at the amount of storage space that you would require. Okay, let's try to estimate the storage space that you would require. Okay, cool. So I would say that let's first of all try to estimate that how many characters of a shortened URL would I actually require. Okay, what do we mean by that? I mean by that let's say the average input URL that you are going to see is going to be 100 character long. Is that a good assumption to make? The input URL being 100 characters long? Cool. Now let's try to figure out what happens for an output URL. Output URL is going to be something like bit.ly / some hash. Okay. Now let's discuss about how many characters should be there in that hashed value. Moe says 6. Okay. If there are 6, let's try to estimate how many. If there are 6, let's try to estimate how many possibilities do we have there. Okay. Right. So we have 36 ki power 6, which makes sense. Let me do that for the class as well, so that everybody is on the same page. So every character can essentially take a 0 to 9 and can also take a A to Z. Does that make sense? Let's assume you do not include special characters, and browsers are generally generally case insensitive. So my URL is generally case insensitive. So let's not have a capital A to capital Z for now. You can actually do that, but for now, let's assume that you can be dealing with case insensitive browsers, and let's assume you have 0 to 9 A to Z. This actually makes it 10 possibilities here. Okay, who is unmuted? Who is unmuted? Is there somebody in the class who is unmuted? I have muted again everybody. Good. Right. So A to Z is going to be 26. So you basically have 36 options. So you have 36 ki power 6 possibilities if you have size 6. What is that value, folks? What is that value? What is 36 ki power 6? Can somebody just use a calculator and solve it for us? Okay. Nobody is replying. Okay. 2 billion. Okay, makes sense. So let's say you can have 2 billion unique hashes or unique shortened URLs. Is that enough, folks? Is that enough? How many URLs did we assume per day? We assumed 1 billion URLs per day. So having 2 billion unique hashes, is that enough? That's not enough. Okay, so I am seeing several yeses in the class. So why are you guys saying yes? So you are not building a system for one day. Is that right? You're not building a system for one day. So if you're building a system for anything more than 2 days, then 2 billion unique hashes are not enough, without a doubt. Okay, cool. So let's, yeah, it will only work for a couple of days then. And then it will not be a $1 billion company, most likely. Cool. So let's actually now try to figure out that how many such URLs do I need to save? So I need to save 1 billion per day, which makes it 365 billion per year. And let's assume I'm building a system for 10 years. How much does it become? It becomes 3.6 TB. Oh, sorry. Yeah. So it becomes something like that. How many requests do you want to see? You want to see 3650 billion per 10 years. Does that make sense? Does that make sense, folks? Right. Now, for this to work, I would think that maybe ये कितना था अपना 2 billion था, इसको 30 से मल्टीप्लाई करेंगे तो 72, 72, 36. हाँ. So maybe 8 characters should be sufficient. Is that right? 8 characters should be sufficient. So we can actually have 8 characters for our shortened URL. Is everybody with me till this point in time? You would be required to do all these computations. In an interview, you would be required to do all these computations. Okay. Cool. Yeah, 36 ki power 8, Archit. So let's assume that you have 8 characters in the shortened URL. Cool. We have that information. Now let's try to estimate for storage. Okay. Let's try to estimate for storage. Right. So Uzair says, but 8 might also be fulfilled at some point in time. That makes total sense, Uzair. It might be fulfilled at some point in time. But the point is that if you are building a system for 10 years and it's not an issue, so we are totally fine with that. You can just maybe have 9 characters and be rest assured that you're not going to hit a limit anytime soon. Cool. Now let's try to estimate the storage. We can increase the alphabet size as well. That's also right, Moise. You can include special characters and you would be then able to, increase the number of possibilities even when 8 characters. Cool. Now let's try to estimate storage. For every URL, you are going to on average store 100 characters for the original URL. Does that make sense? You are going to store 100 characters for the original URL. And we just assumed that 8 characters for the shortened URL. One assumption that I'm making, that you are not going to store bit.ly / every time, because this does not do any information. You do not have any information gained by storing bit.ly because that remains same for everything. So let's not assume the storage space which is going to be required for this storing bit.ly again and again and again for every mapping. So you basically have 108 characters per URL mapping that you have. Does that make sense to everybody? Okay, so now Deepika is asking, are we expecting 2 billion writes or reads per day? So Deepika, we were expecting 1 billion reads per day, which translated to 10 million writes per day. But just to make the problem a bit more interesting, we assume that you are going to see 1 billion writes per day. So whatever we are doing, we are assuming 1 billion writes here. If there are 1 billion writes, you can assume that there are going to be 50 billion, 60 billion reads every day. Okay, cool. So now for the storage, we just saw that we are going to require 108 characters per mapping. Okay, which means 108 bytes per mapping. Okay, and if 108 bytes per mapping and I have a billion of them, how many bytes per day? It's going to be 108 gigabyte. per day. Does that make sense? Storage space is going to be 108 gigabyte per day. First of all, is everybody on the same page that no matter whatever algorithm you have, you are bound to store the URL and its shortened URL, right? Okay. Uzair, I can repeat it. I am saying, Uzair, that every mapping from a URL to a shortened URL would take 108 bytes. Is that correct, Uzair? And if every mapping is going to take 108 bytes and they're going to be created 1 billion new mappings every day, by our first assumption, you're going to see 108 GB of data per day being stored in your DB. Does that make sense to everybody in the class? Okay. Cool. If 108 GB per day, and let's assume I'm building this for this per day, let's now come to per year. So you would simply do 108 into 365 GB per year. That should come out to be roughly 37 TB per year. Does that make sense? 37 TB per year, 36 TB per year. Now, let's say we are building this for 10 years. So the overall storage that you're going to see is going to be, let's say, 360 TB for 10 years. Does that make sense to everybody? So all the questions that we would be solving, we would be roughly talking about 10 years. And for this system to be built, we require 360 TB of storage. Cool. The moment you realize that you should have 360 TB of storage, does one thing become crystal clear to you? That only a single DB machine will not work. Does that make sense? Just because you see 360 DB of per year, per 10 year, now you should tell your interviewer that based on this estimation, I am pretty sure that I require multiple DB machines. Why is this a good assumption to make? I will tell you why. Most of the DB storage machines that we see today can store 1 TB of data. These I am talking about simple machines. If you talk about, let's say, some high-end machines, very, very costly machines, you can assume that they can store roughly 10 TB of data, or let's say 10 to 20 TB of data. Does that make sense, folks? Now, so for storage, if I assume 10 TB storage per box, can you guys tell me how many boxes do I require? 36 boxes, right? So I require 36 DB boxes. Okay. So this translates to 36 DB boxes. Do you guys now appreciate that why these calculations are important? Because you can actually estimate the actual number of required boxes that you can have, that you are going to require, and this can be as close as possible. Okay, so you are going to require 36 boxes for a period of 10 years to store your data. Cool. Now we discussed QPS as well. We discussed 36 DB boxes as well. Now let's actually discuss how many machines do I require to handle the QPS. Does it make sense? So for the storage, using the storage, we computed the number of DB machines. Using the QPS, we are going to compute a rough estimate of the number of app servers. Does that make sense to everybody? So now the QPS that we discussed was 11,000 QPS. Right? We discussed something around 11,000 QPS. Now, let me tell you that the normal systems that you build, 36 for 1 year, 36 machines, 36 machines for 10 years. For storing the entire 10-year data, you are going to require 36 machines. Cool. Now, the normal systems that you make, which are very, very trivial systems, which only end up doing some simple checks, some simple lookups, provide you a QPS. A single box would provide you a QPS of 1,000 to 5,000 per box in a trivial application. Folks, does it make sense? What do I mean by trivial application? An application which is just doing a few lookups. Okay, but this number varies a lot. Let me tell you the reality of the system that I built at Media.net. So there, the system was to actually categorize pages, figure out the best ads. The time it took to process one URL offline was 0.5 seconds. Does that make sense? The time it took to process one URL was 0.5 seconds. And let's assume let's say you have 8 cores on a machine. Okay, and assuming, taking into account the amount of time that it takes to do context switch and amount of time it takes to handle the other parts of the jobs in the box, let's assume at any given point in time, roughly half of those cores were available for my job. People, are you getting what I'm saying? I am just trying to estimate the number of system you are building. Is my voice still breaking, folks? Is it still breaking? It's better, right? Okay. So I will just repeat what I was saying. The point that I was making was that this QPS that I mentioned, 1000 to 5000 per box, is it again breaking? No, it's not. Okay. So this QPS that I mentioned, 1000 to 5000 per box, is for a very, very trivial application. I was giving you an example of the system that I built so that you guys can appreciate that this number can vary a lot. Okay. Whenever you actually do some kind of a machine learning algorithm, you do some kind of back-end processing, as was the case in the API, in the system that we built, was that now you actually end up taking 0.5 seconds per request. And of course, this is not going to be a live request because you cannot actually wait for 0.5 seconds for a live request to be processed. These were offline requests. That is, the requests were kept on being pushed to the queues, and from the queues we were consuming them and trying to process them using multiple boxes. Okay, so 0.5 seconds per request. Now let's assume the box that you had 8 cores. QPS refers to servers. Okay, so Nikhil, QPS generally refers to the server requests. But you can very well figure out the QPS for a DB as well. So for any system, you can figure out a QPS. But generally speaking, you would talk about it in a server, number of requests to a server point of view. Does it make sense? Cache miss is equal to DB queries. That makes sense, Moez. Whenever you have a cache miss, you end up doing a DB query without a doubt. Cool. So I was saying that let's assume that the box that we had 8 cores. Okay, let's assume that the box that we had 8 cores. And let's assume if there were 8 CPUs or 8 cores. Now I was saying that CPU time of one request into the QPS that you have should be less than 4. What does it mean? Let me just tell you. Okay. 0.5 seconds that system was taking on one core. Okay. If there are 4 cores available, what would be the Q? Let's assume there is only one core available. If there is only one core available, what is the QPS for this system in a one core box? Is it 2? Can you run 2 queries per second? Because every query is taking 0.5 seconds. Okay. Yeah. So you can say that you are going to have 2 QPS per, basically 2 QPS if it was a single core box. Exactly. Now, if assume it was an 8 core box, you can say QPS would be. Does it make sense, folks? The point basically is that the CPU time multiplied by the QPS should be less than equal to the number of cores. Does it make sense, folks? QPS basically means the queries per second. If you multiply it by the time for one request, you would get the number of cores. Okay. Are you guys feeling lost? How many of you are feeling lost? I really see that a lot of you would be feeling lost. I just want to have a count. How many of you are feeling lost? Actually, yes. Okay. I will repeat it. I will repeat it. Just give me a second. Just give me a second. Okay. Okay. Yeah, I'm repeating. Everybody, please pay attention here. Okay. Let's assume you have a service which takes 0.5 seconds per request on 0.5 seconds of CPU time. Does it make sense, folks? Let's assume one service takes 0.5 seconds of CPU time. Okay. Now, if you have a 8-core box, right? If you have 8 CPUs in a box, effectively, you would say 2 times. I really don't know what to do. I myself am not feeling well today, and the internet is also not working. Is the voice better now? Do you guys want to actually reschedule this class for tomorrow? Not feeling well, and also this internet is actually bothering me a lot. Okay. Does that really work, or do you guys want me to do it completed today only? I am totally fine with completing it, but the main problem is that the voice is breaking. So just give me a minute. Let me just try restarting the router here. Just give me a minute. If you are, just hold on for a minute. If we can actually, oh yeah, I can try switching off the video. That's a great suggestion, right? So okay, is it better now? Is it better now? Deepika, that won't be the case. If I move away from the system, the voice breaks. That would not be the case. If that was the case, then you would be hearing a slow voice. That's it. But okay, cool. So maybe let's continue it this way with this video off. Cool. So everybody, please pay attention here. What we were discussing. Right. So I was saying that if a particular system takes 0.5 seconds of CPU time per request, and if you want to figure out the QPS that you can have from one box, that is what is QPS? QPS can you run per second? Okay. If I want to figure out the QPS of a box, do you agree with me that the number of cores in this box is also important? Very, very trivial, right? Because if you have 16 cores, so basically 1 real second means 16 seconds of CPU time. Does that make sense? And QPS is computed based on the real seconds that you actually see, right? Cool. So let's assume there were 8 CPU cores. If there are 8 CPU cores, then your QPS would not be multiplied by 8 directly. What would happen? You would actually say that if there are 8 CPU cores, that roughly half of them you would be able to use parallelly for this application itself. But that's a good assumption to make. Okay. if there are 8 CPU cores, you can say that the effective number of CPU cores that you're going to have is going to be 4. Does that make some sense? Why have I reduced this 8 to 4? Because I am factoring in the context switches. Etc. Does this make sense to you folks? Okay. Once you assume that the effective number of cores that you have is 4, and you know that one request takes 0.5 seconds of CPU time, can you figure out the QPS per box here? It's going to be 8. Does this make sense? Very, very trivial. Right, cool. Now, just let's, this is just the ancillary information that I wanted to give so that you guys understand the kind of, this is what you would realize if you actually work on systems yourself. So this is some kind of a rough estimation that you should have in your mind. That is the only reason why I actually came here and discussed this. 4 is less than equal to 8. What does that mean, Archit? That's a perfectly valid statement to make. I can tell you that. But what else do you want me to discuss about it? 4 is less than equal to 8. Okay. Okay. So the formula that I was trying to give was that the CPU time. So Moez is enjoying the class. He's saying 1 is equal to 1. Right. CPU time of one request, when you multiply that with the QPS that you have, that should be less than equal to the number of effective cores that you have. Just look at this equation and try to take it home and just try to figure out, does it make sense, does it not? It would definitely make sense. This is a very, very trivial equation that I'm writing. Okay, cool. This is done. Now let me just give you one more piece of trivia, after which we can move back to what we were discussing before. One simple piece of trivia would be that if you want to discuss about the RAM accesses, or let's say if you want to discuss about, if you were doing some RAM accesses and you want to figure out, RAM access basically means that you're just serving some things from the cache. Then if you want to figure out the number of time, the amount of time that it takes to figure out one piece of information from a key value pair in a RAM, for that I would suggest you that the time would be, first of all, the context switch time. Actually, let's just skip this. Whenever I see a better utility of this, I will add it there. Discussing it right now just makes it more complicated. Okay, so let's not discuss it right now, but don't worry, I will give whatever information I want to give at one time or the other. Okay, so do not worry about it. This is something that you guys should be able to understand now. Let's move ahead. Okay, so I was talking that our system that we just saw had a QPS of 11,000. Where did that QPS came from? That came from looking at the number of requests that you see, number per day there are in a day. One thing that I told you guys some time ago, that never assume your number of requests to be stable throughout the day. Okay, never assume that. The graph that it follows is generally this kind of a graph. There is some point in time in the day when the number of requests actually increase a lot. So if the average number is something like this, so let's say average was 11,000, you can very safely assume that the highest number that you are going to have is going to be double of that. Does it make sense? So if you are trying to figure out the number of systems that you should have, you should actually figure out for the peak load of 22,000. Does it make sense, folks? But will you be running throughout the day 22,000 के हिसाब से number of boxes? That won't be the case. You would definitely have a scaling up and scaling down throughout the day. But let's assume for now that if you want to figure out the number of boxes that you're going to use in the worst case, use 22,000 there. Cool. Now let's come back. I was telling that a very simple, makes sense, Abhishek. This is just the write QPS. You also need to discuss the read QPS. Okay. Now, as I was telling you, in systems when you are just doing simple lookups, the QPS per box happens to be between 1,000 to 5,000. Okay. For simple systems. For complex systems like the system that I just told for Meteor.net, the QPS there was 4. We just computed that. We started with 8. Right? So the QPS can actually vary from a single digit to, let's say, 1,000, 5,000. Okay. What is the maximum QPS that there is any system in this world? The maximum QPS of very highly optimized, very simple systems can actually go up to 1 million. And this would be very shocking, but this is just a piece of trivia for you guys. Okay. For all our computations, you should be using this kind of a range if your system is very simple. Okay. Does it make sense, folks? Now, if I have 22,000 requirement of QPS and one box can give me 1,000 QPS, the number of boxes that I'm going to have in the peak load is going to be 22. Any doubt? No doubt. Now, just one more thing to take care is, ideally, running your systems at 60% load. So whatever boxes you computed, you should ideally divide that by 0.6. Does that make sense to you guys? Folks, does it make sense? Okay. Is it breaking again, Sankalp? Okay, yeah, I can repeat it. So I was saying that ideally you should be running your boxes at 60, 65, 70% of the load. Why is that the case? Because the moment you run your boxes at much higher the load, the chances of your box going bad increases many folds. Does it make sense, folks? The chances of your box going down increases many folds. This is a practical thing that you should know. And also, in case of sudden fluctuations in load, the scaling up and scaling down always takes a few seconds before the box becomes ready. So to manage those sudden changes in load, you should always take into account that you would be running every box at 60% of the capacity. Or you can assume 70% of the capacity if you want to save some money. Okay. So you would estimate, according to all this, that you would require around 40 boxes to run this. Does this make sense to everybody? We figure out the number of DB boxes. We figure out the number of boxes for computation. Okay. Let's now move ahead. Cool. So we have done a lot of computation and I hope that you guys understood it, and we would be able to do this for all the questions that we see thereafter very simply. Okay. We spent some time today. We would not be spending this much time in all the classes, but in your interview, you should definitely be doing this. Okay. Cool. We have done that. Now let's actually come to the third point, which is very important, which is making the right trade-offs. Making the right trade-offs. So the first of all, let's talk about latency. What do you guys think? What can we say about latency? What can we say about latency, folks? Can we afford a higher latency? We cannot, right? Latency should be very low. The reason being that this system is just like a DNS system. Does it make sense, folks? The system is just like a DNS system, because all the shortened thing is doing is to just redirect you to a different URL. And if that service starts taking a lot of time, the users would be very, very unhappy. Okay. And this is exactly how you should make arguments in an interview, that this just looks like a DNS service from an end user's point of view. And this should be very, very fast. So latency should be very, very low. This is a must. Cool. Now let's come to SCAP theorem. By all the calculations that we did, do you understand that P is a must? Partition is definitely going to happen because things are spread across multiple boxes. Now it's basically boils down between consistency versus availability. Now, first of all, before making a decision of what is consistency, what would you select and what would you not, it's very, very important to understand that what do we actually consistency here and what do we actually mean by availability here. Because I've seen so many people who do not get this right for every question, right? It's very, very important. For different question, it means different things. Can anybody in the class volunteer and tell for us that what does consistency mean here? Can anybody volunteer and tell us what consistency means here? Okay, Chandan raised his hand, so let me unmute Chandan. Hey Chandan, can you hear me? Hello?
Am I audible?
Yeah, you're audible.
So according to me, like consistency would mean here, let's say there are two users who are trying to create a certain URL, so they should not be assigned a same code.
Makes sense. So one part here is for consistency, the first thing here would be that two URLs should not be, two different URLs should not be mapped to the same hash. Does it make sense? Two different URLs should not be mapped to the same hash. Does it make sense to everybody? Here, consistency would definitely mean this for sure. Does consistency mean anything else as well here? Yes, consistency here means one more thing, and that basically is that if you have a shortened URL at your system, and if a user tries to access that shortened URL, you should always consistently tell it that this is the actual URL. Does it make sense? You should not tell the user that this URL does not exist when it actually existed. Okay? Should not reply back with a shortened URL does not exist even though it existed. Does it make sense to everybody in the class? These are the two basic things which define consistency for this problem. And I would want more folks to reply. Very few of you are replying. I would want more of you to reply. Cool, it makes sense. Right. Now, let's discuss the availability thing. Availability here simply means that if a user wants to access bit.ly, he or she should be able to do it, right? If the box is up for which the connection is made, he or she should be able to access it. This is what availability would mean. Now you guys tell me, what is more important for a service like bit.ly? Okay, consistency, 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 consistency. Consistency and eventual availability. So, Suganya, there is nothing like eventual availability. The point is कि eventually तो everything will be available, right? So ऐसा तो नहीं होगा कि यार मैं box बंद करके घर चला गया कि nothing is available, right? कि मैं यार एक काम करता हूँ, तार काट देता हूँ और सो जाता हूँ क्योंकि availability तो नहीं थी. So eventually तो everything would be available, right? So there is nothing like eventual availability. Availability basically means that something which is something, if the box is running, you should be able to access it. That's it. Consistency में होता है कि you have right number, you have immediate consistency or you have eventual consistency. Eventual consistency means that you would allow some time before you can claim that everything would be consistent. Cool. Now you guys tell me. Okay. So Sankalp says that we are okay if a URL is down for some time. So Sankalp, understand, it's not a URL being down. For some users, bit.ly would be down. So even if everybody in the class, please appreciate, I created a shortened URL. I shared with all of my friends. The URL, the actual URL is perfectly fine. If you go with the actual URL, you would be able to hit it. But just because bit.ly is not available, nobody of you would be able to access that URL. Does that make sense? So do you think it's good for a bit.ly to be down, to be not available? It's totally not acceptable. Bhai, you had one job. The only job that you had was to tell me where my URL is, and you are down. So availability is very, very important for a service like bit.ly or a service which does URL shortening, because this is just like a DNS. Would you want your DNS to be down? Because if your DNS is down, no matter if the internet is up, you would not be able to access anything. Folks, does it make sense? People are not replying. Okay. So just because this is a DNS like a service, availability here is a lot more important than consistency. And most of you said the exact opposite when I asked it for the first time. Doesn't to everybody in the class. If there is anybody who wants to have a discussion, please let me know. So availability here is super important. Availability here is super important. It would be a very bad experience for the end users if you are not able to access your shortened URL at all. So availability here is much more important. That's it. Consistency, of course, would be important, but we are fine with consistency. We would want to reduce that time as much as possible, but immediate consistency is cool. This is done. So we discussed latency, we discussed CAP theorem. Another thing that I want to point out here is one kind of a good to have feature here would be that the shortened URLs that you have should be as small as possible. And we have all answered this in the previous question. That 8 actually storing these shortened URLs. Cool. Now we have discussed this. Let's now actually come to the fourth point, which actually deals with system design. Okay. Any doubt till this point in time to anybody in the class? I hope not. One thing that I would just want to comment on consistency and availability here, taking a more relatable example. Let's assume you are messaging, or let's assume you are on Facebook. Okay. So now Facebook being unavailable basically means when you try to log in Facebook and search for a person, let's say I want to, and Facebook says that, hey man, I'm down right at this point in time, I will not be able to tell you whether Mayur exists or not. This is being unavailable. Being inconsistent is that I asked Facebook that, hey man, is Mayur there? Can I find Mayur here? And Facebook tells you that no, there is no Mayur. Does it make sense? So that would be inconsistency for a Facebook case, in that specific finding friend wala case. Does it make sense, everybody? Similarly here, if somebody comes and say, I want to access this bit.ly ka shortened URL /abcd, and the bit.ly telling you that, hey man, I do not have any mapping to this shortened URL, that is being inconsistent for a while. But bit.ly saying that, hey man, I'm not able to service you at all at this point in time because I'm down, that is being unavailable. No matter how bad it looks, bit.ly saying that /abc does not exist when it actually existed, no matter how bad it looks, but that is still better than bit.ly saying that, hey man, I'm down for you, I do not know what to do, please wait. So that's a very, very bad system to build for a system like DNS. Cool. We have discussed this. Let's now move to the fourth point now and discuss how we would actually look at the architecture here. Let's draw the diagram that we all love drawing. You have a client. The client interacts with the load balancers. The load balancer then interacts with app servers. We figured out that there should be at least maybe 40 app servers that we discussed, computed, so somewhere around 40 or 50 app servers that we have here. After the app servers, we should have storage layer. And we discussed for the storage boxes as well. As far as I can remember, maybe we discussed 60 storage boxes. Okay. Now we need to figure out that what all things do we store here at the storage boxes? How does the control flow look? And what kind of a cache do we have if we want to have any cache, and so on and so forth. And how does all the things that we want to do actually happen in this case? Does it make sense to everybody? Let's try to answer these things one, and then we will be done with this question. Okay. The first thing I want to answer, that what kind of a data would I want to store in my DB boxes? Okay. My submission is that for the features that we have selected, we would essentially be storing key value pairs. Does that make sense? Here key would be nothing but the shortened URL, and value would be the actual URL, comma, I can say maybe the user who created that URL, maybe a expiry time, and so on and so forth. Does it make sense to everybody? Ayushi, you are right. We did not have 60, we had 36. You are right. Cool. So these this is the kind of values that you would want to store. Then maybe if you want to do some analytics as well, then you would want to have some different tables where you would be doing some analytics as well. Okay. That for each shortened URL, you would be saving some kind of a demographic information, some kind of a number of counts of accesses, and so on and so forth. Cool. Now you guys tell me, for this data that we are going to spread over 36 boxes, do we already know that this is going to be sharded? Do we already know that this is going to be sharded, folks? Yes, because we discussed that one box will not be able to fit out all the data. So this is definitely going to be sharded. Can somebody tell me a good key for me to shard my data? Can somebody tell me a good key to shard my data? My submission is that the shortened URL hash would itself be a good key. Does it make sense? The shortened URL hash would itself be a good key. So it would be sharded based on the key, which happens to be the shortened URL hash. Does it make sense to everybody? Cool. So we now know that how my data is stored in the DB layer. Now let's come to the app server. So first of all, you guys tell me, do I require a consistent hashing here? Do I require a consistent hashing here? Okay. So many yeses, some no's. Okay. So let me ask a different question before that. Do you think this is a stateful system or a stateless system? Do you think it's a stateful system or a stateless system? Stateless, 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 right? Abhi tak it's totally stateless, right? If there is no state in the system, would you want to have a consistent hashing? You would not want to have a consistent hashing, right? You would just be having a round robin and heartbeat mechanism to know which all boxes are up, which all boxes are down, and that would be more than sufficient for you guys. Does it make sense to everybody? That's great. So this is a stateless box. There is no need of any consistent hashing at this layer. You can just have a round robin with some mechanism to understand, heartbeat mechanism to understand which server is alive, which server is down. Okay. Now, one more thing. When down, okay, or when a server comes up, read about a thing called Zookeeper. Would you read about it? Read about a thing called Zookeeper, which allows us to do that without any issue. Okay, I would be discussing most likely Zookeeper a bit today at the end of this lecture. But even if I don't, take out some time and read about Zookeeper. If you want, I can share some resources as well. Yeah, that's the spelling, Sukanya. So Zookeeper. Let me just write it here. Cool. Okay, let's come back here. So this is a stateless system. Now you guys tell me, how would, without cache till this point in time, how would a flow look like here? Okay, let's say you want to come and make a new mapping. Okay, so you come with a big URL and you want to access a shortened URL. So what will happen? You will come here, the load balancer will redirect you to any of these boxes, right, in a round robin manner. Let's say you go to this box. Now what should happen, folks? What should happen? If I have a URL, I want to get a shortened URL. What should I do thereafter? Okay, is the screen stuck? Okay. Compute the hash value for a big URL. Okay. So now, where would you compute that hash and how would you compute that hash? Okay. First of all, where would you compute that hash? Should I compute that hash on the app server? Makes sense. That's a possibility. Now you tell me what should be the key for the hash. My submission would be that the key for the hash should be the URL plus maybe a timestamp plus maybe a box ID. Do you think that's a good key to have? You can just pass this information in a hash and you will get a hashed value. Does that make sense? Okay, the screen is stuck, so I will be resharing my screen so that the screen is visible to you folks. Very sorry for this bad experience. Don't know what to do with it. I've complained several times, but okay. Why box ID? Makes sense. Why box ID? The point is, if the key that you are inputting to the hash function, should be as diverse as possible. The point here was that all of these boxes are running at the same time. Let's say two users come at the same time with the same URL. No matter how small the probability is, but still there is a probability. Does that make sense? Two users come with the same URL at the same time, and the timestamp is going to be the same, the URL is going to be the same. To make sure that these two things have one more parameter of randomness, I just added a box ID. You could have added a box ID, or better, you could have added a random noise here. You would have just have added a random noise here, and that would also have been sufficient. Does that make sense to everybody in the class? Right. So now you get the value. The problem here is that the value may already be being given to somebody else, some previous mapping as well. Does that make sense? Is that possible? That's totally possible, because a hash function is going to take a set of very large values and is going to map them to a smaller value. Okay, smaller set, only a set of size 8 characters. Okay, now just because you have a smaller set on which you are mapping, you are bound to run into duplicates. And also, when the number of requests that you are handling is of the order of 1 billion per day, you are bound to run into some duplicates. Okay. So now there is a pending problem of solving how to look for duplicates. Can you guys help me with that somehow? Do you know, can you think about a way of figuring out how to look for duplicates? Can anybody just volunteer and let us know how to look for duplicates here? Okay, Mohini will want to do it. Let me actually unmute Mohini. Hey, Mohini.
Hey, hi. We can have, like, we know that the length of the socket URL may be 6 character, 8 character. We can have another service where we can create that URL and we can pass.
Okay. So you are saying that there can be another service where you can check whether this is a duplicate hash or not. Is that what
No,
you're
no,
saying?
no, no, because we are creating right now the URL in the app server,
Okay.
that hash key. Maybe we'll have some service which will give you the every time a hash key which we can assign to the URL, and that have the information that is already created or not.
Okay, that makes sense. So you are saying that let's have a let's have a common service here, which is a hash generating service. Every app service is going to call that common service and going to get a hash value for the URL. Now
Yeah.
you are that okay, that makes sense. But the point still remains that how will that service realize if that URL is already being created or not? Again, you will have to store that information. Does that make sense?
Yeah.
And would you be able to store all the hashes that you ever generated in a cache, or would you be wanting to store all of them in a DB only if you want to store?
Cache will not work, I guess, cache, because we need all the data. Like,
So you will be actually be having to store in the storage there only.
yeah.
Irrespective of whether you actually go with a common service or with separate app server mein hash generations, you are bound to go to that common DB where you can figure out whether that particular hash exists or not. Does that make sense?
Yeah.
So you're bound to do that. The only difference here is that if you have a common service, the probability of hitting collisions reduce a lot, because the point is that all of them actually go to the same service, and the same service giving you the same hash again would relatively be low.
Yeah.
Okay, so that makes sense. But the problem there would be that you are introducing a single point of failure, and the moment you introduce a single point of failure there, you would want to have that service also as a distributed service, and then the problem would just become a lot more complicated. Does that make
Okay.
sense? So
Yeah.
at this point in time, just because we don't have that big a requirement of having a common service to generate all the hashes, I would be more than happy than generating the survey, more than happy than for generating the hashes at the app servers themselves. And the moment you generate it, you can just do a check if that particular hash exists or not.
Okay.
Cool. Thanks a lot for volunteering, Mohini.
Thank you.
Does it make sense to everybody else in the class as well, what we just discussed? Right, cool. Makes sense. Now, Deepika has a question. DB are sharded according to the shorted URL. So go to the particular DB and check exactly, Deepika, exactly. So just because the DBs were sharded based on the keys that you had, basically the shortened URL wala hash that you had, now you can go to the correct DB and just try to figure out whether that key exists or not. Okay. Now to go to the correct DB, would you guys agree with me that there should be a consistent hashing after this layer, which will tell you which particular DB to go to? Right. So there would be a consistent hashing layer hashing at this layer, which would tell you which particular DB do you want to go to. Makes sense. Now, Suhail says, can you please explain how to figure out whether hash is duplicate or not? Exactly, Suhail. So what I'm saying, let's say you at this box generated a hash which was, let's say, AXEBCDF. Now what do? You go to this consistent hash, figure out that if this is a key, what particular box will that key be located at? Consistent hashing will tell you, let's say, that this key, if it's present, would only be present in this box. Now you go to this box and somehow figure out whether this particular key already exists in one of the entries in this box or not. Does that make sense, Sohaib? Cool. Now there is one very interesting thing here. Understand that if you do not store these keys properly in the table, you would realize that figuring out whether a key exists or not would be a complete scan. Does it make sense? Folks, does it make sense? So it would be a complete scan if you do not store these keys properly. So these keys should be ideally stored. Okay, so now there are two options. Okay, so folks, first of all, I'm sorry for the bad internet and I'm also sorry for my bad health. But please, this is very, very important. Please pay full attention here. Now, do you understand that it's very, very important to have these keys in some ordering? Otherwise, you will end up at every check, you will end up checking the entire box, the entire table. Folks, does it make sense? And that's a very, very bad solution. There would be billions of keys in that box, or at least millions of keys in that box. You would not want to scan through all of them to check if that particular key exists or not. Can anybody in the class, okay, Archit has given the answer without even me asking, indexing. Nikhil has also said that you guys would want to do indexing. Think about it. Do you really want to do indexing? I would want everybody in the class to think about it. Do you really want to do indexing? Ideally, you would not want to do indexing here. The problem with indexing is that indexes are very costly on writes. Does that make sense? Indexes are very costly on writes. Because the moment you write it, you will have to rebuild the index, and that will take a lot of time, and you cannot do that. Right? You cannot do that. Now, how would you go about figuring a way of doing this now? The point here is we would be actually discussing NoSQL in the following days, but the point here is that the key with which you are storing your data. So ideally these would be NoSQL boxes and not SQL boxes. The key here of storing the data should be such so that it orders itself and allows you to do some kind of a binary search rather than a complete linear search. Does it make some sense? The ordering of the keys stored in this box should be such that you will not end up scanning the entire box in trying to figure out whether a particular ID exists or not, but there is some inherent ordering in the key and you can just do some kind of a binary search there to figure it quickly. Yes, Sankalp, we will be discussing this when we discuss NoSQL. Just hold on for a while. There are ways to do it. So I will just give you one example. Let's say the box, the NoSQL DB that you are using, automatically sorts things based on keys. Okay. So Uzair says, isn't that what we do in consistent hashing? Uzair, consistent hashing will allow you to figure out which particular box that data is in. But that's not enough, right? You also want to avoid scanning the entire table and figure out where that particular thing will exist. Does that make sense, Uzair? Right. So that's why it's very, very important that for scan queries, you should be able to scan them effectively. And we will be discussing that when we discuss, let's say, HBase in the further classes, that how to design a key such that the scan becomes efficient. Do you guys make some sense out of it? Do you guys get some sense out of it? Okay. So Nikhil says our primary keys indexed. That's right, Nikhil. You can index primary keys, but as I told you, indexes here would not be very helpful. Sankalp says here we have 100 to 1. Can't we have indexes because indexes are faster on reads? That's right, Sankalp. But the problem is if you're having 1 billion writes based on the assumption that we have, and if you're going to update the index 1 billion times, not 1 million times, maybe 1 billion divided by 36, if you have 36 boxes, these many times if you are going to update an index in a day, your system is going to be very, very slow. Write time will increase for sorting. Makes sense. Makes sense. So we'll be discussing that in the further classes, that how to actually do that. But that actually makes sense, Manish. It would be increased. Cool. We have discussed that. Let's now discuss about a cache here. Does it make sense, folks? Let's discuss about a cache here. What happens if there is a collision? If you realize that yes, this key was already created before, what would you do? If a key was already created before, you would simply generate a new key. Does that make sense, Vijay? You will simply generate a new key. Folks, are you with me? Good. Okay, we are about to end this very quickly. Let's now discuss a couple of more things, and then we are good to go. Cool. Right, exactly, Abhishek. That is what we want to discuss after we discuss the cache. Now, you guys tell me, these are stateless systems. First of all, do you think a cache would be helpful? And if it would be helpful, what kind of information would a cache store? Who would want to volunteer and explain that to the class? Would a cache be required? And if yes, what kind of information would a cache store? Okay, Nikhil can try first. That's great, Nikhil. Yeah, hey Nikhil. Yeah.
So, hello.
Yeah, please go on.
Yeah. So basically, till now we discussed how we can write basically URL to a shorthand URL and save it, right? Now the points come basically when we want to read the basically from shorthand URL to the URL, right?
Makes sense.
So right. So for this, I feel maybe we can use the app server cache with the stateful request kind of.
Okay, okay. So just hold on to that thought. First of all, everybody, let's discuss how a read request would happen, right? So let me use the blue pen to describe the read request. So the client comes with a shortened URL to the load balancer. He or she wants to read it. Now the load balancer is going to actually redirect that request to any of the app servers because this is totally stateless. The app server is going to pass that hash to the consistent hashing, go to the exact box where it could be located and check if it is located. If it is located, it will just figure out the value of it and return that value back to the client. Does that make sense? Very, very simple. If it did not exist, it will just tell that this mapping I do not have, man. Please try again, or maybe there is some issue, I do not have this mapping. Cool. Now the problem is that these read requests, you are bound to go to the server, the DB server every time. So that is not a good system, right? Now, Nikhil is suggesting that let's have caches, and he is saying that let's have an app server cache. The moment you have an app server cache, Nikhil is intelligent enough to understand that you would want to make your system stateful. Do you guys also appreciate that? The moment you have app server caches, you would want to have your system stateful. Does it make sense? Yes. You would have to have your system stateful because if you have cache in a particular box for a particular key, you cannot just go to any other box for the next call and then you would not be able to hit the cache and then you'll again be forced to go to the DB. So if you want to build it a app server thing, then you must be having a stateful system. But is that the best way to go about it? Or do you think that having a global cache and still keeping a stateless system would be a better approach?
Global cache here I feel can be more useful in the case. So basically we can accumulate more data into that cache. As we discussed, we can use the flash boxes in which we can accumulate more data in one box.
Exactly, that makes total sense. So a global cache here would make more sense because first of all, if you make it app server based, then you are essentially not allowing the best utilization of your resources, right? Well, ideally it should be similar only, but there will be some difference in the utilization First of all, because you have one extra hop, you will actually going to be a consistent hashing wala box, figure out the consistent hash, and then go to the specific box and then look at that particular cache. Does it make sense? Here, having a stateful system for only these requests does not make any sense. If you actually end up some more features to this, which makes it a lot better to have a stateful system, then maybe we can disband our global cache and take our app server caches. Does it make sense? Nikhil, does it make sense to you?
Yes, yes, yes.
Okay, so you're absolutely right. Let's have a global cache here. So let me just build a global cache here. So you would be having a global cache here. What kind of a replacement strategy would you want to have here?
Replacement, most basically, which is most used, I will like to keep it that.
Makes sense. So most frequently used would be a good strategy. Least recently used can also be a good strategy, because LRU in all practical, most of the practical purposes,
Practically that is.
comes out to be a very, very good replacement strategy. But yeah, MFU can also work here. Okay, cool. Thanks a lot, Nikhil. Thanks a lot for volunteering. Thank you.
Thanks also.
So does this system look very, very trivial to everybody in the class? And the primary reason why it looks very, very simple is because we have understood the basics very well. And after today's class, everybody would be able to know that how to approach any problem. Does that make sense? There is one more thing that we want to discuss in this class, but do you guys appreciate that going forward, when we are going to build complex systems, you know what 4 points to do, and you know what calculations help us in what manner, and only those calculations are going to take help us doing the design decisions and actually come up with a design at the end. Cool. Any doubt till this point in time? Any doubt till this point in time? There is no doubt, right? Cool. I have a suggestion to key generation and duplication problem. It may sound odd, but just came and we'll discuss it for sure, Sameer. Let's discuss it. Let me unmute you, Sameer. Let's see what alternate solution you have. Hey, Sameer.
Yeah, hi, Tarun, can you hear me?
Yeah, we can hear you.
Yeah. So I have one solution suggestion. I don't know whether it's right or not. I just wanted to discuss it. So we had like key generation duplication problem. So what I was thinking is like we already have ranges of hashes that are assigned to a shard, right?
Okay. So there are not range.
Let's assume it. Okay. So what I was thinking is maybe we can have a key generating DB, and at the app server, what we can do is like we can at the key generating DB, we will be having offset and the count of the keys that we have already generated. Let's say we have 40 shards right now, so we will be having 40 offsets, and we will be having for each offset we will be having the count of keys that we have generated from that offset. And at the app server, we will generate a random number modulo 40, that is the shard that we have. And we can just send this number to the key generating DB, and it will respond with us the new hash key that we want to provide.
Sameer, I did not get it completely, but I would just try to rephrase it. And if I'm understanding it wrongly, please correct me. So what I understood is you are trying to assign fixed ranges of hash to every DB. Is that correct?
Right.
You are maybe trying to say that let's assume your hash values happens to be between 1 to 1 lakh. So you are saying that, and let's assume there were 4 boxes. So you are saying 1 to 25,000 key values are going to sit in the first box. 1 to 50,000 is going to sit in the second box. 50 plus 1 to 75 is going to sit in this box. 75K plus 1 to 100K is going to sit in this box. This is what you're saying?
Right.
The very first problem with this approach, Sameer, is that itself, the problem of, let's say, what happens if you have to add a box or if you have to remove a box, right? The moment you have to add a box or remove a box, would you agree with me that the ranges change drastically?
Right.
The moment the ranges change drastically, the problem would be that you will have to revamp all your data. You will have to move all your data to your boxes. And when you end up doing that, if you are moving billions and billions of records, you are definitely expecting some kind of a downtime, maybe for 6 hours or maybe 12 hours.
Right.
Is that a valid solution in your opinion, Samir?
No, no, at the DB level it is not.
Yeah, you understand it, right? So that's the primary reason why we actually came to consistent hashing, because if we give fixed ranges, you do not leave your problem scalable. The problem then becomes कि अच्छा इसी scale पे चलेगी, इससे बड़े scale पे नहीं चलेगी, क्योंकि you have fixed everything. And let's say if a DB box dies tomorrow and I have to now run with 3 boxes instead of 4, that again won't be possible, because to do that you will have to move a lot of data and that will encounter a lot of downtime. Okay.
Right.
Thank you. But still, I appreciate that you raising that point. But I hope that now you will always remember that why having fixed ranges is not a good idea, right?
Right. Right.
Okay. Okay. Now Sankalp says, can we please have estimation of cache, DB storage limits for servers summarized at one place? Maybe in the next lecture. Okay. 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 So Sankalp, abhi we did discuss that in today's lecture and in the last lecture. If you want me to summarize it, maybe I can write it on a sheet of paper and share it with you guys. Or maybe in the next lecture, I can take out 5 minutes and write it again. Good suggestion, Sankalp. I will do that. Nikhil says, any estimate on how many global cache boxes should we use in this kind of tiny URL? Okay. Okay. So what was the, okay. So Nikhil and everybody else in the class, what was the amount of data that I told you one particular SSD can store? Flash drive can store in the last class. Do you guys remember that? Makes sense. So I told you that it can store roughly around 70 GB. Okay. So actually SSDs can actually totally fine. Now here we would want to figure out the idea of figuring out the number of boxes would be that how many URLs do you assume are going to be the most frequently asked URLs in a day? मतलब how many active URLs do you see in a day किसी भी random दिन पे? मतलब my idea would be कि जो बहुत ज़्यादा 80% of time जो URLs use हो रहे होंगे, that would be of the order of, let's say, 0.75 billion, or at the worst case, let's assume 1 billion. Do you guys appreciate that? कि मतलब at any given point in time, at any given day, the amount of URLs, the number of distinct URLs that a service would be serving very frequently would not be more than that order. Once you have that order in mind and you know the amount of space that it requires to save one entry in the cache, you can figure out that matlab, based on the last competition that we did, we would be actually requiring 108 GB of data for 1 billion records, if you guys remember that. Let's assume to be on the bigger side, let's assume to be 120, 140 GB. Okay. So now if you have to store 140 GB, 200 GB, maybe 3-4 flash drives would be enough to handle all your cache. Does that make sense? But that does not make you immune from not going through the DB at all, because cache by definition means that you are going to handle it most of the times, but for several times you're actually going to end up in the DB, which is totally fine. Does that make sense to everybody? Right, Nikhil. That's based on our estimation. Now, let's actually discuss data replication and duplication in our DBs. Should we do it? Okay. Abhishek says, any specific reason we are going with NoSQL here? We can even use SQL DBs. Makes sense. Makes sense. So we can actually use SQL DBs here as well, Abhishek, without a doubt. The point for using NoSQL here would be that SQL, as I told you, come with its own set of transaction handling capabilities. Did we discuss that in any of the classes till now? SQL boxes, SQL DBs actually come with their own set of transaction handling capabilities. In these kind of systems where you do not see any, okay, we did not. Okay. So let's actually wait for a while, Abhishek, before we actually have a class in which we discuss NoSQL versus SQL. After that, maybe we will be able to comment on it then. Does that make sense, Abhishek? If we did not discuss it at all, then let's not discuss it right now. Makes sense. So the point is, till this point in time, whatever we are designing, we are not using the exact. Is in this system, if even if you use a SQL box, nobody is going to come after you and say that I'm going to reject you just because you are using a SQL box here. So all the things that we have done till now did not actually depend a lot on SQL or a NoSQL DB choice. Okay, I will make it a point that before we start discussing systems where that makes a lot of impact, I would be discussing SQL versus NoSQL with you guys. Does that make sense, Abhishek? Okay, but I was under the assumption that we did have some kind of a discussion for 5-10 minutes. If we did not have it, maybe we can have it in the next class. Cool, but we are going to have one class dedicated only for SQL, NoSQL, and other things in the storage here. Cool, so we have discussed this. Let's now come to discussing how data would be replicated. Okay, so there is one box where there are different DB boxes. You have some data stored there. First of all, you would agree with me that there will be a totally different cold storage layer. Do you guys agree with me? There will be a totally different cold storage layer where data would you will keep on taking backups so that you remember that your data is there persistent. Okay. Now, at the storage layer itself, my submission is that having just a single box is not going to be a very good solution. Let's have a group of boxes there. Does that make sense, folks? Does that make sense? Let's have a group of boxes there and not have just a single box. Having a group of boxes, you have two basic solutions of having a group of boxes. One is that you can have a master-slave architecture. The other is that you can have a peer-to-peer architecture. Do you guys appreciate that? Okay, voice is breaking. Is my voice still breaking, folks? Okay, it's better now. Okay. So there are two ways to go about it. One can be a master-slave architecture, the other can be a peer-to-peer architecture. Let's discuss the master-slave architecture first of all. No, this is not for the app server box. This is for the DB boxes, Sukanya. Sankalp, it's right. Masterless, you can just call peer-to-peer masterless because there is no master in a peer-to-peer network. Everyone is equally capable, just like everybody else. Okay, cool. Now, the idea is that let's discuss the master-slave architecture first. There is one master and there are multiple slaves that we have. Okay, Nikhil says in this cold storage layer is not there, right? Okay, Nikhil, the point is that first of all, if you have this master-slave architecture, the requirement of that cold storage becomes a lot less. But let's say you end up, let's say there are some URLs that you're not going to use and you want to flush them out of your DBs and store them in a cold storage. Nobody takes away that right from you from having a cold storage layer. Does that make sense, Nikhil? You can still very well have a cold storage layer. Nobody is stopping you. For the replicas, these replicas I'm talking in the storage layer, not in the cold storage layer. I hope things make sense, Nikhil. Cool. Okay. Now, if there is a master and there are multiple slaves here, one thing that we know is that the read to write ratio is 1:100. 100:1, right? In this bigger ratio, do you think that every layer above this layer should only be interacting with master? It's not good, right? Because if for every request you're only interacting with master, that's not maybe the best way to go about it. A better way would be that you can do all the writes on master and you can do the reads from slave. Does that make sense? Right. So you can do the writes to master and you can do the reads from slaves. Makes sense. Now let's discuss about availability versus consistency. One approach that you can have is, if you are reading from master slave, understand. The point is that let's say somebody created a mapping for, let's say, www.scalar.com / let's say candidates. somebody made a mapping for this URL, and this was mapped to, let's say, bit.ly/abcd. Okay. Now, when you are writing this, you definitely write this into the master. ABCD के साथ mapped है www.scalar.com/candidates. Now, there are two ways about it, as we discussed in the previous classes. One way is that you will only give back a reply to them once you have persisted this to every slave. That will ensure full consistency. Does that make sense? But that would hamper the availability a lot. How would it hamper it? It would hamper it because let's assume there is one slave which is unavailable, you would not be able to accept your requests, and that's a bad thing to do. Does that make sense, everybody? Neeraj, you're absolutely right. So that is not a good solution. So let's not do it. The second solution that you have is that when you write to the master, just write to any one of the slave. Just write to any one of the slave. At every frequent interval, these slaves will keep on interacting with each other and will keep on syncing up the data. And you are fine that you know that at least one slave has it. I am fine. So even if the master dies, there will be one slave who would have it, and one of them will become the new master, and that master will have all the data. Does it make sense, folks? The second extreme case that you have is, rather than waiting for every slave to record that write, let's just wait for at least one slave to record that write. People, are you with me? That's the second extreme that you have. But what is the problem there? You have very high availability because all you want is just two boxes working, the master and one of the slaves, and you are fine. But the problem there would be that consistency would be very, very, very bad. Because how will the read happen? The read will happen by randomly coming to any one of the slaves. If the read happens and it comes to any one of the slaves, let's say it comes to this slave, but that particular write happened at this slave and no other slave has any data about ABCD till this point in time, then what will happen? This box will tell you that ABCD does not exist. Now, if ABCD does not exist, even if your system is totally available, but it's the probability of you showing not available when it's actually available would be very high. Folks, are you with me? So that's again a bad strategy. How to fix it? There is one way to fix it, that you can go with the waterfall model. What does it mean? That you will hit the first random slave. If you have it, you will simply reply back. If you do not have it, you will go to any other slave randomly. Again, repeat. You will keep on repeating it unless and until you explore all the slaves. Because we are damn sure that at least one of them will have the entry. So if you explore all the slaves, you will be sure ki theek hai yaar. If I now say that there is no entry, there is no entry at all. What is the problem in that case, folks? The problem in that case, as Uzair is rightly pointing out, that the latency would be very, very high. Does it make sense to everybody in the class? If you end up following the waterfall model, the latency would be very, 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 very high. Now, what else do you have to do? One very good strategy that finds the best of both worlds and actually is a strategy which actually works is that you are the master, you have so many slaves. Now, once you are writing, you will record a write after you get confirmation from more than n/2 slaves. Let's assume there were n slaves. You will record a write once you receive confirmation from more than n/2 slaves. Does it make sense? Folks, does this strategy make sense? Now, one bad point of this strategy would be that the latency is increasing because you are waiting for n/2 of them to write. But appreciate that this latency is a write latency. And that is something that we are fine with. Folks, are you with me? That is something that we are relatively fine with, having some sort of a write latency. So you wait for n/2 of them to record your response, and then you send back a done to the person sitting above you. Okay. Now, this is for write. What happens for reads? The read again is going to go to any of the random slaves. Now you tell me, if at least half of them had the entry, what is the probability that that entry existed and that entry also existed in this box, in this slave box? What is the probability? It would be 1/2, right? So 50% probability you can say is that this box will have the entry that you're looking for, if that entry actually existed. Let's say now this box did not have that entry. So what will you do? You will select any other random box, and let's say you select this one and check here. What is the probability of you being this unlucky कि even this box does not have the entry that you had, even though it was recorded somewhere else? The probability will become 0.5 multiplied by 0.5, which is 0.25. And let's say you do it for the third box, it becomes even smaller. Let's say you do it for the fourth box, it becomes even smaller. So you will keep on doing this, and you will beyond, you can just maybe do it for 3-4 boxes, and you can be very certain beyond a reasonable doubt that this entry does not exist if it did not exist in the first 4 boxes. Does it make sense to everybody in the class? Does it make sense to everybody in the class? That's great to know. Now you would agree with me that now you are still compromising on consistency. There still would be cases when people actually recorded something and you will be telling to the user that, hey man, I did not find any entry. But that is fine with us. Maybe that user will hit a refresh button and that will come again to us. And maybe the next time around, we won't be that unlucky that we will still not get the entry. Does it make sense? Because these are multiplicative probabilities. And for things to fail again and again, the probabilities become infinitely small. Does it make sense? Does it look like a good strategy of having good availability and having decently fine consistency as well? And for sure, we have eventual consistency. And this also has low latency. So have we had the cost of slightly higher latency, Sukanya? The slightly higher latency is only a multiplicative factor of 3 or 4, which is totally fine. We are not actually going with every single box. And also appreciate that that is also a probabilistical latency. The point is there is a 50% chance that you will get the value from the very first entry itself. Does it make sense? There is a 75% chance that you will get after the second thing itself, and so on and so forth. So it's also a probabilistic latency. It's not a real latency. I hope things make sense to everybody in the class. Does this look like a good solution of handling this? Low latency, very good availability, and decently good consistency. And one thing that you must not make a mistake here, that we must appreciate that availability here is much more important than consistency, because this happens to be a DNS like a system. It's not acceptable if you tell your users that, hey man, bit.ly is down, even though we don't know whether your URL is down or not. Cool, it makes sense. Now, one more small comment. If you actually want to ensure that you have 100% consistency, do you agree with me if you end up doing n/2 + 1 checks, and if you still don't get it, you would be practically sure that that entry did not exist? Because you are only maintaining a write when you actually write it to n/2 places. And if you end up checking more than half of them and did not get any entry, you can be 100% sure that that entry never existed. But that's again an extreme thing to do. Nobody would be doing it. Oh, okay, Sukanya. Is it better now, Sukanya? Cool. So you have done this. The second strategy that we wanted to discuss was pure peer-to-peer. Okay. Pure peer-to-peer would be something like this, that there are so many peers. Whenever you want to record a write, you will go to any one of them And then these boxes will keep on interacting amongst themselves, updating amongst themselves. Whenever a read comes, you will just read anywhere, and then you will figure out. If you do not get it, you will go to some other place and so on and so forth. But this is not the best solution for this kind of a problem. A master slave architecture, as we just discussed, would be a very good thing to solve this problem. Is everybody in the class clear with the solution now? Cool. Okay. Right. Okay. Okay. So let's actually wait for peer-to-peer. We will be discussing peer-to-peer again in the further classes. I will just tell you that this solution here would be that every box is as good as any other box. Okay. So there is no master here. You can record the write in any one of the boxes, and you can try to read it from any one of the boxes. These boxes will keep on communicating amongst themselves and keep on sharing the latest entries that they have. Okay, so Abhishek says peer-to-peer is multi-master synchronous cluster. Okay, let's not go there. Peer-to-peer is just is a group of servers where there is no preferential treatment given to any one of the boxes. Exactly. BitTorrent uses P2P. It's not like a ring network. Let's not discuss P2P right now. We will be discussing that somewhere down the line. Cool. So I think things should make sense here. Yes, things should make sense. People, can we end the lecture now? Okay. Yeah. Thanks a lot for attending the lecture. I am again sorry for not being in the best of health today, and also for the bad internet. I'm really sorry for that. Okay. Yeah, I will take care. Thanks a lot, Suganya. Thanks a lot, Sankal. Nitesh says, can you recommend any books for HLD? Okay. So, Nitesh, I would suggest just hold on for a few more lectures, and then I will suggest some resources to you. Okay, Nitesh? Can you provide your LLD lectures? Okay. So, I did not take any LLD lecture recently. Most likely, I will be taking it for the next batch, and I will share those LLD lectures then with you, Ayushi. Is that fine? Just wait for a while. Once I take the LLD lectures for the next batch, I can share those lectures with you. Okay. Okay. Yeah. Thank you. Share the entire lecture PDFs. Okay. That's a good point, Chauhan. Prithvi, I will do that. Sakal, that's a very good book. That's a very good book. Tomorrow is a leave. So is there any class tomorrow? Why is it a leave tomorrow? What special day do we have tomorrow? Okay, I'm sorry, I do not know. Okay. 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 Is it Ambedkar Jayanti tomorrow? I was not aware. Sorry. Okay. So I will just have a look. Most likely it's not a leave tomorrow. Do you guys want it to be a leave tomorrow? No. Fine. So if you do not want it to be a leave tomorrow, let's not have it a leave. Okay. Fine. Sure, Swapnil, I can actually share the DP lectures with you. I will share the DP lectures with you, Swapnil, for sure. Just drop me an email so that I don't forget. If you have already dropped an email, I am sorry, but I will just ensure that you receive the lectures. Okay, Jose. Okay, Swapnil, I am sorry if I missed that. I will share them. Okay. Abhishek, do you, okay. Makes sense, Abhishek. Makes sense, Abhishek. The point is, I thought that it would be better to actually mix and match the things before, rather than just having so many basic classes and then discussing some systems. The point was that for today's discussion, do you feel there was any prerequisite that we missed? I do not feel that. But if you feel, we are free to have a discussion on that. The point is that we will be keeping on interleaving classes like this. We will have some design classes where we actually design some systems. And at the same time, we are going to have classes where we discuss some basic concepts. The point is to just to make sure that it does not become very boring and does not become very long. That's the only point, Abhishek. For sure, Nikhil. For sure, we can have that. Maybe we can have that discussion on microservices versus monolithic in this module, or maybe we can have that when we are going to take the backend classes. Because if we are going to take the backend classes, when we discuss the backend classes, in that it will also make very sense to discuss microservice versus monolithic. But yeah, I will plan accordingly. Can we get example of interview session link of HLD so that we know when and what to end the discussion with? Interview session link. Do you want us to record some real life interviews and share them with you? Okay. We'll see if we can do that, if that's feasible and if that's also possible, because I'm not very sure if we should be recording those sessions and sharing them because of the privacy issues and so on and so forth. But yeah, you guys can actually have your mock interviews with your mentors and TAs. We will be scheduling some of the mock interviews so that you know how well you are actually tackling HLD questions. Okay, Nitesh, so are you missing on the company questions? Do you guys want to have the company questions periodically? Are you guys missing them? Okay, Sukanya, Nitesh, you two are missing them. What about the others? If you guys are missing them, I can ensure that we have at least one such class every week. Is that fine? Having one class every week? Cool. So we will be having one class this week for company questions. Cool. Point noted. Anything else, anybody? Cool. Thanks a lot for attending the class. And let's hope to meet you guys tomorrow. Bye. Good night.